Thank you very much, Catherine, and for all the work that you do on this. We have a great set of speakers today, and we're going to be reviewing basically each of the 3 tracks that are going to be at Where 2.0 this year. Over the past couple of years, the Where space has really moved from mapping to mobile, and with increasing mobile data sets, it's become more important to the local industry. So looking initially at how mapping has been changed by mobile, we have Diane Eisner, who was originally of Placial, which was kind of one of the first Where 2.0 startups, and is now with Waze, which is a company that makes its money off of real-time data sets generated by users. So they're generating real-time maps. Our second speaker is Joe Stump, who is formerly architect at Big and is now working on mobile web services, specifically web services that help mobile developers handle an influx of geodata. And he's going to talk about how that is changing the mobile industry. And finally, we'll follow that up with Karen Nortman of City Search, who's going to be talking about local trends, both in data and user usage of that data. And without further ado, I'd like to welcome Diane Eisner.
Hello. Am I unmuted? Hello? Can you guys hear me?
Yes, Diane, we can hear you.
Okay, perfect. All right, well, let's
We're
just
seeing your desktop.
Perfect. Okay, so we are focused on what we call live mapping, and really it's about people using an application on their smartphones for navigation. And we're collecting GPS traces and building up a highly dynamic map data set and real-time traffic and road information at the same time. So it's really the intersection of crowdsourcing and real-time geoprocessing and information. And I have shown a number of real-time map examples and these kinds of things in the past, but I thought I'd just start by showing one of my favorite, more recent examples you may have seen from the recent TED. And this is from Bing Maps, and it is a static image, geolocated, that is showing real-time video on top of it. And it's a crowdsourced image, so I think it's another really wonderful example of merging those two things to create something that's actionable. When we get to the point where we can actually see what's happening in real time as much as possible, we can make real decisions about where, for example, in my case, where traffic congestion is, and we can plan routes. So that was just a snippet there to start off. Now, the problem with crowdsourcing, in the geospace, we've been doing this for a long time, is that it's really hard. The typical metrics that you see in social media is, 1 to 2% contributor, and then the rest of the people are just being able to have access to this information. So most crowdsourcing fails to create value. And so we needed to look at how can we increase the level of participation. And that's what this talk is going to be about. So we looked at crowdsourcing in the navigation space. And navigation is one of those areas that's completely in flux right now. And not all of the reasons are relevant to each other. They're kind of orthogonal. But we've got smartphones becoming more and more pervasive. We've got what was a duopoly becoming something that is, it's easier for people to create map data sets now. So we see a worldwide series of alliances as opposed to that kind of control and dominance of the past. We see the static information of those map services going more toward the real time. We see the licensing fees in the navigable data market going down. We see the costs going down. And we see location advertising going up. So there's just a tremendous amount of activity in this space. So when we think about crowdsourcing, we think about applying it to the navigation space. So one of the most important things is you have to get people away from using navigation as something only when they're afraid to get lost, once per week, once every couple of weeks. And so we're trying to build a series of services that are around daily driving. Obviously, we're going to get better traffic and road information and better updates on the roads the more people drive. So basically, it works like this. People drive around. We collect the GPS traces. We start to be able to create a road grid around these when we have enough data to be able to get a higher level of accuracy from the GPS traces. So that's the road grid. Then people come to the website and they attribute road names, street numbers, this kind of thing on our map editor. Then as people continue to drive, we're able to create traffic based on historically what we have in the database. We're building up now information on average speed per road segment per time of day. So when people drive, we know if they're going slower or faster than that. So most of what people have to do is just turn it on and drive. And just for turning on the application, they're creating value for everyone else. So we've got 100% participation. Then beyond the passive, there are, you can see the little car icons there, police icons, road hazards. You can actually report a feature. So that brings us to the second point. How do you get people engaged enough to contribute more and more value? So if you have 100% people contributing information, we look at how to make things fun. And in the geo space, there's a lot of fun right now. We've got My Town, which I think in 2 months has had something like 1.5 million downloads, and it's iPhone only and US only. And for those of you who don't know, My Town is a game that allows people to, it's kind of Monopoly meets the real world. You can become an owner of your favorite properties in your city. And then I'm sure all of you know Foursquare. So we look at what's happening, and we were very early in this as well, but to go back to daily driving and how to make it fun, we do a few things. So this is Waze. And when you start using Waze every day, we start to learn your patterns. It's something that learns over time. So we can say, okay, good morning, Noam, you driving to work? We look at the routes you normally take to work, and we tell you what the ETA is today. So again, it gives people a reason to use it every single day. Those are the routes. You can also see other Wazers in your area. So those pink and green and red icons are other people using the application right now. And there are small green bubbles over some of those icons, which those are people who have opted in to allow you to ping them. Now, you cannot text while you're driving, but if you're stopped or if you pull over or if you're a passenger, you can ask people about road conditions and imagine that there's a distributed network of road reporters out there, and that's how people are helping one another in the community. One of the most prominent features is that in the U.S., for example, we started with a tiger-based map. So we already had a pretty accurate road grid, but there are a lot of gaps. So what we wanted to do is make sure that we validated all of the roads. The roads that you see there that have dots, that's where no one yet has driven using Waze. When that happens, your icon will turn into a Pac-Man-like creature, and you'll start eating those dots and gaining points. People like that feature so much that they asked for routing not just based on the fastest ETA, but on the maximum points, so you can get that as well. We've also begun geocaching these virtual goods in areas where we have gaps in the map data. So one of the things about Tiger is that it's a display map. It doesn't have turn restrictions. It often has even a 1 pixel disconnect in the map will allow us to not be able to route properly. So where we have those map errors, we put these caches of points. And so if you go slightly out of your way to be able to munch these goodies, then you'll continue to get points in the game. And once in a while, we even put real objects in the virtual caches. So this was a little promotion we did, and we gave out movie tickets around Valentine's Day. Obviously, people want to know within their area who's got the most points, and so you're able to track on a weekly basis how you're doing against others. And additional social features. So you can report these events, which help us complement the real-time information, traffic loads and accidents and things. You can also, when we think of daily driving, it's not just when you're moving, it's also when you get to your destination. So you can check into Foursquare. If you do it 3 times through our service, then you can unlock the Road Warrior badge. And you can tweet your ETA. So these are just small things that when you add up, we're trying to create a lot of value in your whole daily driving experience. The results for most of the gaming campaigns that we've done are that about 25% of our drivers participate, and on average, we've increased the kilometers per user by 150%. And we're seeing people really stick around a long time. People are averaging 25 to 35 minutes per session. So we're getting good data. Now, fun is all well and good, but it only matters if you're able to turn that into value. So here's the Bay Area, and this is the Tiger data. I apologize that it's pretty light, but this is what we got from Tiger. This is segments that we updated either through people driving, and this is just in a 2-month period, by the way. I should mention that we just released in August of 2009 in the U.S., and this is a snapshot taken in November, so I guess 3 months. This right here, where you still see red, it's segments that we updated where Tiger was either inaccurate or didn't have any information at all. That can be our users creating new roads that weren't on Tiger. It could be that the Tiger data had a very poor location. So you can see the bridge up there on the upper right-hand side. There's a very light gray line underneath it where they just had the bridge in the wrong place. So everywhere you see red are the segments that we updated that have made the Tiger map from a display to a navigable map. Where you see the gray dots are turn restrictions. It's where we've learned you can take a right, you can take a left, where you can't turn, so we're learning about that. And where you see the red are where we have the active reporting. Now, you look at a country like Israel, where we launched in January 2009, we obviously have the most data. But you can see that this map is well marked. You've got POIs, you've got live people driving every day, you've got real-time traffic being created, and you can learn where the turn restrictions are, so we've got a navigable map there. All of that adds up to the fact that we're already today making money on the map data, but also, more importantly, on the real-time information. Even the Ministry of Transportation today is paying us to use our traffic information. They've done pretty rigorous benchmarking, us versus existing methods, sensors in the road and this kind of thing, and they've determined that we were more accurate. And this is the kind of thing that obviously reinforces that functional value that's meaningful to us. So this was on a morning where there was, I guess, a bike protest, and we were able to route them around it and get them to work in 35 minutes as opposed to 75. That's what we care about. This is a little outdated. This week we passed 600,000 drivers. You can see those numbers at the bottom are weeks of the year. So at the beginning of 2009 was our Israel launch, then the USA launch, and then in November what we did was we opened internationally. And we started it the way we started in Israel, which is no base map whatsoever. You start with a white screen and you actually see yourself building the roads. I guess I should note that we have map editors as well. So most of the drivers, again, they don't go to the website and edit, but we do have those who go to the web, they edit, they add names where we need them, and then we have local area managers who are volunteers. Now, unlike a pure wiki format, you have to have, you can only edit within a 1-mile radius of where you've driven. So we really want only locals to be editing this. And then within that, we have these area managers who are super users and have rights to edit a polygon in their area. They also review the changes that are made in their map area. So you see that tiny blue blotch there in the center of the slide. This is Israel, and that's where we started. We've got the U.S. with the Tiger information. We've got user-generated content in the rest of the world. And then we started doing something pretty cool, which is we started creating these worldwide partnerships. And our first partner we launched recently with, called Location World in Latin America. They're based in Ecuador. And they have actually given us a complete commercial-grade display map. We put the client, our application on smartphones using their map in their area, and then we both share revenue on both advertising and on licensing that information. So we've got these partnerships happening around the world, and by the end of the year, with a focus on Latin America, Asia, some of Eastern Europe, we expect that we're going to have commercial grade in many areas the best navigable map in real-time road information that exists. These are new kilometers created weekly. Now, let's see, and then the number of new countries. I have to make the distinction between new because we're in about 85 countries now, but you can see countries with new kilometers every week. It's almost everywhere where we have drivers. We've got new information happening every week. Our base map is updated every 24 hours. So if you drive something today, it's in the map tomorrow. And that's one of the most unique things about the service. You can see a breakdown there. A lot of our usage is in Israel, where we're already well past function, well past critical mass. We've got good growth in the U.S. And then right now we're just lumping the rest of the world together, but it's growing very, very quickly. Now I want to show you just briefly some live information. This is people driving right now, right this moment in Europe. We have done another deal with Intermap for road grid information in some of these areas. So we had very, very quickly people building up. Oh, sorry, I have a little bit of a stall here in my internet connection. So we have, we're getting away from this blank white screen very, very quickly. In Italy, for example, every road you see here was driven by a user, the road names added by users, and it's growing very, very fast. In Italy alone, I think we have now over 30,000 drivers, and it's a very, very active community. Then I'll show you the difference. This is Ecuador. Right now, again, this is live. And you can see the level of detail in this map. It's because even though it's not a navigable map we started with, it's our partner Location World has very good base map data. And these are live people here. These are road reports, and this is traffic being created as we speak. This is the Bay Area right now live. And I'll show you where it points to. This is Israel live right now. So this is after 8 o'clock at night, and we still have this many people on the road. That's about it. That is Waze. Hello?
All right, are there any questions for Diane? We've got time for maybe one or two. Well, I'm not seeing any come by, so I think we'll move to Joe. And Diane, if you could just stick around and watch in the comments for anything that comes across.
Of course, will do.
Thanks. And thank you very much for speaking.
You're welcome.
Now we have Joe Stump, who's founder and CTO of Simple Geo. And basically they are kind of creating a geo version of Amazon Web Services. Please welcome Joe.
Ironically, we're creating them on top of Amazon's Web Services as well. So my name is Joe Stump. As Brady said, I'm founder and CTO of Simple Geo. And I wanted to chat a little bit about using NoSQL to store GIS information. So a little background before I get really started on this. Simple Geo actually started out as a location-based gaming company. And as the Waze guys, I'm sure, can tell you, along with a lot of iPhone developers, the Foursquare guys and whatnot, we're in an interesting area right now where geo information is being crowdsourced and required to be real time and stuff like that. And the traditional GIS tool sets, like the PostGIS of the world, have difficulty scaling. Relational databases in general have problems scaling. Location information in particular is difficult to partition because of natural hotspots. Depending on how you partition it, it can be difficult to partition your data by location. For instance, if you put a server that's handling New York City and a server that's handling Yankton, South Dakota, the server that's handling Yankton, South Dakota would be pretty bored, and the one that New York's on would be would be overloaded. So enter NoSQL. So the first thing I wanted to talk about is what exactly is NoSQL. NoSQL covers a wide range of various storage systems, databases, key value stores, and basically the thread that joins them all together is that they don't have relational features. They don't have traditional relational features. So you can forget about joins. You can forget about unions. You can forget about having pre-canned indexes on dates and stuff like that. So, and then of course some examples. There's really a lot of fragmentation and movement in this area because generally when people create a NoSQL store, they're creating it for a very specific reason. So you have things like document storage engines like CouchDB. You have column stores like Cassandra, Dynamo, Bigtable. Dynamo is Amazon's, Bigtable is Google's. Those are both proprietary, but there are white papers written on them. It's pretty easy to find out how they work and how the tech was put together. Cassandra is actually a byproduct. It was written by a guy at Facebook who had previously worked at Amazon on Dynamo, and it's essentially a combination of Dynamo and Bigtable. React is another one that's been put together by some people, I believe out of MIT. It's written in Erlang. It shares a lot of characteristics with Cassandra. Redis is another really popular one. That's a key value store. MongoDB is a fairly new kid on the block. That's kind of more of what people are calling an object store. SimpleDB is Amazon's generic database in the cloud. There's of course Memcached, and MemcacheDB is essentially Memcached with a persistent Berkeley database backend on it. And those are literally just a dozen out of probably 3 or 4 dozen projects that are going on right now. So at SimpleGeo, we use Cassandra. We really when I was looking at the various relational NoSQL stores that were out there, I really only had one serious hard requirement, and that was that the partitioning of the data happened automatically within the system. Cassandra has this really great infrastructure internally for handling the partitioning and querying of keys across hundreds of servers. I think at SimpleGeo right now we have somewhere in the neighborhood of 15 to 20 Cassandra servers running in a cluster, and we can literally bootstrap a node into the cluster in about 5 minutes. So it can literally go from a bare bones Amazon instance to being a full-fledged in production instance in about 5 minutes. And the way that Cassandra handles that is they have these internal token ranges where you can essentially say, you are going to handle this token range, and then the new kid kind of comes on the block and says, hey, I'm the new kid on the block, and this is my token range. And everybody else that's in the cluster says, oh, there's somebody new on the block. Let's feed him some of our keys. And it automatically rebalances and redistributes the data internally. So, in fact, right before I came online, we had a client launch a new product recently called Sticky Bits, and a lot of their queries were going to a single node on the cluster. We rebalanced those queries based on the token range without having to bring anything down or anything, without any side effects on uptime. So just a little bit about Cassandra. A row is a collection of columns, which is very similar to kind of how SQL works, except for columns are arbitrary. So you can have one row that has 15 columns. You can have another row that has 100. And then of course you can have as many columns in a row as you wish. Rows are uniquely identified by a single key, which roughly translate to a primary key in relational stores. And Cassandra has this really weird thing, super columns. And super columns is kind of where most people get lost in Cassandra's data model. But basically a super column is a special type of column where your column can then contain many more columns. And then one of the other nice things about Cassandra in comparison to a lot of the other NoSQL stores is that you can actually do key ranges. So those primary keys, you can do a start and a stop key on them, and as well as a limit. So some reasons that we chose Cassandra. The first of all, Cassandra was really built with the A and the P from the CAP theorem in mind. For those of you that don't know what the CAP theorem is, the CAP theorem states that in distributed systems, in distributed computer systems, those systems can be highly consistent, they can be highly available for writes, or they can be highly tolerant to network partitioning. And CAP states that you can only have two of those. So Cassandra is eventually consistent, which means that if you write something into the system, it may not be replicated across the entire system for a couple hundred milliseconds or something like that. Another reason we chose Cassandra is that it's currently in production at Facebook, as well as Dig and Rackspace and a few other places. At Facebook, it was built to build cheap B-tree indexes, and they are using that right now if you do a live inbox search in your inbox on Facebook. And there's, I don't know, 150 or so machines in the cluster there. Dig has probably a couple dozen that are in production. I know one feature alone has 76 billion keys in the cluster. Not a problem. One of the interesting things also about Cassandra is Dig and Facebook and a few others have found that there's no reason to use caching. Cassandra will easily handle in the range of, I've seen anywhere between 7,000 and 11,000 writes per second per node. So if you have 10 nodes in your cluster, there's really no reason that you can't handle 70,000, 80,000 queries or writes a second. And then of course it scales in an N+1 fashion. If you need more writes and you need more reads, you just simply add more nodes. And as I've already mentioned before, adding nodes into the cluster is extremely trivial. So those are just a few of the reasons why we chose Cassandra. If those sound appealing to you, other options in this area would be Project Voldemort and React. They are very similar to how Cassandra is put together, just with some slight variations. So the anatomy of a column. This is essentially what a normal data structure in Cassandra would look like. This is a very rudimentary view of how we store some of our data at Simple Geo. And you'll notice the first key here that's highlighted in red. That's actually a geohash dot and then a record ID. So that's the key that I was talking about earlier. And then in that record are various columns. So we have lat, lon, city, and state. So that's the basic structure of what a column looks like in Cassandra. Many other document stores and key value stores have a very, very similar structure. I'm not going to cover super columns because they are a little weird and they have some limitations and stuff. So if you're interested in those, I'm happy to answer questions on those, but I'm not going to be covering them in detail here. So how do you do a search? Cassandra allows for generic key range queries, which let you scan for all records. And this is something that we do internally as well, that start with a certain geohash. So we've been using geohashes internally. And basically in SQL terminology, you would say select star from rows, where geohash is like something %. And Cassandra does that and actually will map that across multiple nodes. So for instance, it knows internally, because of the token ranges, it knows that out of all of the keys that start with DR5, REG, Y3Z, that 1,000 of them are on one node, 500 are on another, and then 2,000 are on another. And what it'll do is it'll actually map that across 3 different servers and merge those results and return them to you. So we have a few uh-ohs here. First of all, as I'm sure many of the GeoWonks in here are aware, geohashes have edge cases that create certain bounding issues, especially where the meridian and equator cross. Those 4 sections have completely different prefixes. So if you were attempting to do a radius query around that, you would have problems with that. And I'm going to show some other things with that as well, some other issues with that as well. Doing complex polygon searches with geohashes is extremely difficult as well. And one of the problems with that is if you want to search by a triangle, or some other complex polygon like an octagon. Geohashes are, of course, they roughly translate to bounding boxes. So you basically have to do some tricky stuff on the back end with merging those results and doing multiple queries. And then obviously the other problem too is that if you have someone that's on an iPhone, geohashes may not uniformly cover the bounding box that they're currently looking at. We've run into a couple other issues with geohashes. Geohashes, of course, don't take into account altitude. They don't take into account time either. So as we've been moving into this real-time location space, it's been, it's become, very apparent that time in time boxing is very important. So doing that requires some extra hacks and tricks. And then, of course, the lack of altitude is becoming more and more important as we get better GPSs in our devices and people continue to work in sky rises and stuff like that. So just a few of the issues. So the first issue I want to cover, the first problem that we had with storing data in Cassandra was that this is a basic radius query, right? We have someone that's in the center of the circle, and they would like to know about points in the circle. Well, in order to get a geohash that actually covers that entire circle, sometimes they're really big. So this is our geohash that encompasses this entire circle. Well, one of the problems with Cassandra, when you give it a common prefix that encompasses an entire circle, is that you end up with this issue here, which is, a lot of the points that Cassandra is returning is actually outside of this circle. So it became really resource intensive to get basically get points that were in the circle because, for instance, if you can imagine that the circle, there's really, maybe this is an open area in a federal park, for instance, and it's surrounded by campgrounds. Well, there's a whole bunch of stuff in the campgrounds, but there's not anything in the open space. So therefore, you might have to filter through thousands of points until you actually got 25 that were in the circle. So this was one of the first issues that we ran into when we were using Cassandra. And then another issue, so our solution to this was, of course, well, okay, let's take that same circle and let's compute a bunch of geohashes that are within this circle. And then we'll have a rough approximation based on geohash bounding boxes where we can do a query and find stuff that's in the circle. This works pretty well. One of the issues with Cassandra and some of the other ones is that when you work at scale, your mortal enemy is I/O. And if you look at how many bounding boxes there are in how many bounding boxes there are in this circle, you're looking at potentially dozens to hundreds of queries depending on how big that radius query is. So if you have to wait on round trips for every single one of those, you run into a lot of issues. So we had to do some very interesting hacks on Cassandra to be able to run multiple key ranges in parallel. And then moving on, some final thoughts. This is just Brady wanted me to kind of give a quick intro to what we were doing at Simple Geo and the weirdnesses that we've encountered with this. One of the things you definitely have to do is your filtering and your final filtering of which records belong in a response needs to be done in memory and process. So what that leads to is you actually end up requesting more records than you actually need to satisfy the query. So you may request 50 keys when you actually only need 25, and you find out that of those 50, there's 35 that are worthwhile putting in there, and then you restrict that further down to whatever the client actually asked for. So that's one gotcha. Another one is you need to always say the last key associated with a query. Because of the way that Cassandra works, you need to have that last query or that last key to continue paginating through the results. So that can be a little tricky. So what we've actually had to do at Simple Geo is assign every request, every GET request, a unique request ID, and then when they come back, they feed us back that request ID, and we can pick up returning results from where we left off based on their last query. And then another thing that works really well as well is HTTP long polling, which is where a client opens a connection and you immediately start feeding data down to them. And it may take you 3 or 4 seconds to finish feeding all of the data that they want, but they can immediately start representing that data as it comes down. So you can imagine that someone, if they're searching for points within Manhattan, they could post a polygon that roughly represents Manhattan. And obviously we have millions of points in Manhattan, so we could basically keep that connection open for a couple minutes while we're feeding a couple million points down the pipe. And then finally, I'm Joe Stump. You can hit me up on Twitter if you have further questions afterwards, if they didn't get answered or you thought of them afterwards. So with that, I will hand it back over to Brady.
I think we have time for just 1 or 2 questions, and Paul Ramsey wants to know what you mean by undetermined query.
Undetermined query. Which slide was that on? Can you explain the undetermined query?
Oh,
he gets it now.
Mind. Paul understands now. Okay.
Okay.
Well, if you could just stick around for a minute, that would be just to stay on the in the chat in case there are other questions. That would be great. Otherwise, thank you very much, Joe. And
no problem.
Now I'd like to welcome a Senior VP of City Search. City Search has been around for a long time, and they are definitely experts in local data and advertising, and Kara is here to share some of her thoughts on it. Please welcome Kara Nortman.
Hi, everyone. I'm Kara Nortman. I'm the SVP of Publishing at City Search, responsible for traffic across our owned and operated properties and increasingly across our CityGrid network. Today, I'm going to discuss really the creation and distribution of local data and content first, and the impact of real-time and new forms of community-created content on sort of the local model. So just to sort of launch into this initially, let me start by telling you from where we've come, and I'll give you a sense of our philosophy, and then I'm going to dig into some industry trends. But this is where City Search began. We began as an individual site some 15 years ago, and over time we've evolved to a portfolio of owned and operated sites, City Search, Urban Spoon, and Insider pages across the web and mobile. Now, these sites are important in that they are kind of direct conduit to consumers and merchants. We really view them, though, as a lab for our CityGrid network, which I'll get into in a second. So, this is the place where we obviously create, engage, we create content, we engage with consumers and merchants, and we try to structure and present it in a useful way. But the ultimate goal here is to develop a series of web services, features, and content to push out to a network of publishers. We fundamentally believe in sort of the open distributed model. So moving right into that, you'll see on the next slide here. For those of you who haven't read anything about our CityGrid distribution model, this is really where the main thrust or the core of the business today, where we've basically taken the core data listings and content largely generated from our owned and operated properties, and we push that out to a large network of publishers. We wed that content on the other end to advertising budget, so it really is a local content ad network. This again speaks to the philosophy we have, and I think kind of broadly the web has now, which is no single site is going to serve all consumer and merchant needs today. It's really becoming an incredibly fragmented universe and market with the variety of sites and mobile applications, Facebook, Twitter, Google, etc. It's a world in which consumers and merchants should be able to engage with content wherever they'd like, however they'd like. And so you'll see visually here an example of a restaurant, Katana, which was also actually on the prior page, where we've taken our core forms of content, so the core listings data, historically the phone number, the address, the web address, and increasingly we include things like social media details, Facebook and Twitter, pieces of content that can be anything from an editorial message, a message from the business, user reviews, menus, photos, videos, etc. and we provide partners with access to that core listings data and that content through basically whatever means is easiest for that publisher. So widgets, APIs, and feeds. And again, that content for us is advertising. We allow merchants to understand where we have budget against that content, and interaction with different pieces of content is a billable event. So we both give publishers access to the core listings data and the content to improve user experience, and then, oh, by the way, we help you make a lot of money. In terms of sort of leads generated to the advertisers on one side and value delivered to the consumer on the other side, we think it's really an industry-leading ad product. So just some kind of background information that provides some context for the way in which we see the world evolving. High level, some of this may not be news, some of it may be news, but local search is dramatically outpacing sort of the overall growth of search. Consumers are becoming more savvy around how they search, and merchants are getting more and more content up, so those searches are gratifying. Some really interesting trends that we are carefully tracking are sort of trends around Facebook and Twitter. The number of small businesses with a page on Facebook has basically doubled over the last 3 months. There was a big announcement, obviously, yesterday with Facebook's location-aware functionality coming out, and they're really making a big play to be sort of the home for the merchant. The second piece of interesting information is that 10% of small businesses are now using Twitter, and that's pretty consistent with the data we're seeing across our site, which I'll get into in a second. And then, just generally speaking, as the queries are there and sort of the local content impressions are there, the ad dollars are shifting, and it's really kind of a local advertising, we believe, based on the data we have internally, is a more efficient way to reach a consumer. It's more likely to lead to a valuable action by the consumer, walking into a store, cashing a coupon, making a phone call to the merchant. So you're seeing the ad dollars shift accordingly from national to local. We believe it continues to be the single largest online revenue opportunity out there. So, kind of moving from the specific city search to the more generic, the industry is generally moving from sort of these authoritative single source databases of data listings. So, the Axiom's and InfoUSA's of the world, where you take these data sets and you push them out. And then maybe you maybe historically hired some people to have internally who might stumble upon an inaccurate listing and would fix it, and then would create content against it, to really kind of a truly crowdsourced model. And you have the extremes on both sides, right? You have the extreme sort of authoritative model and the extreme crowdsourced model. You see companies on the crowdsourced side like Living Social and Foursquare and Gowalla, whose data sets may be entirely actually user-generated. So they provide incentives, obviously, for users to go out and create a listing for them. You want to check in at your local Starbucks, and you notice your local Starbucks doesn't have a record in application, and you want to check in for whatever reason. You want a badge, some sort of other reward, and a loyalty point incentive, and that is the incentive for the crowd to go out and create data. We look at the core data set as sort of the heart and lungs of our CityGrid network, and so we take a bit of a hybrid approach. We start with kind of the authoritative record, and then we engage our community and our partners to help us scrub that data and cleanse that data and make sure the data set is as accurate as possible, which is really kind of a Herculean task when you think about the fact that 25% of local businesses go out of business or are started each year, so 25% of 15 to 20 million businesses. So on the crowdsourcing side, for example, on across City Search, Urban Spoon, and Insider pages, we probably do anywhere from kind of 50,000 plus corrections and new listings additions each month. Now that unto itself is exciting, but the real work comes in actually figuring out how accurate that information is. So a lot of time spent around moderation and cleansing and automated processes for actually taking that data and making sure it also is good data. Moving into the next slide. This is a slide that's probably pretty familiar to everyone. It's just, if you think about, CitySearch has been in an interesting position in that we've been developing local content for the core website for almost 15 years now. And, the model's really evolved from the early days where you had an editorial message and hundreds of paid expert editors building content, and an advertiser message where you had a sales force going out and sourcing that from a merchant, to the first real big innovation was the user-generated review. That still, though, is something that you have sort of the classic contribution kind of the rules. The 1% or less of unique users will typically create a review. Why? Because they probably had an extreme experience, or they were invited to a pool party, and to get access to that party you had to write a review. And then it may take 10, 20, 30 minutes to write a review that's pithy and exciting and engaging. And what's really exciting is we've seen sort of that typical type of user-generated or community-generated content just explode into multiple different forms over the last few years. So, everything from digs to check-ins to, kind of limited character tweets and status updates. And so that's very exciting. We have all new forms of data and content that are now potentially very interesting and useful to the local consumer and merchant. Absolute key, though, is how to take these new forms of data and content and actually make them useful. The signal-to-noise ratio is quite high. So many really sophisticated users may actually follow tweets in their Twitter client of choice about the hot new Italian restaurant or the local deal at their massage salon. But most consumers and most merchants don't kind of sit in front of their tweet deck all day and create groups around keywords that might be interesting to them. So the real key challenge is how you take these things like check-ins and tweets, and you make them really relevant, and you put them into a use case and a context that's familiar. So I'll provide an example of what we've done here at CitySearch. And again, this is a great example of a kind of taking content, a new form of content, and creating a series of applications and features around it that we ultimately build on CitySearch and then look to push out and distribute to a partner network. So everything I'm about to talk about in the next couple weeks will be available through our self-service publisher network to the hundreds of publishers out there that we serve. So this is an example where we basically took Twitter content and took sort of, and structured it against a business listing. And Twitter's made this easier, obviously, with some of their lat-long coordinates, et cetera. But you'll see here that, again, rather than kind of fishing through the Twitter sphere to try to find content about a particular restaurant or business, what we do is we pull that in, we aggregate it, and it's essentially a new form of review. We've created a module specifically on that business listing page where both consumers and merchants can log in and communicate with each other. So you have the dual benefit of a new form of review or content that's really real time, and the opportunity for consumers and merchants to communicate directly, as opposed to, kind of a more traditional review, which tends to be a lot less interactive. On the merchant side, equally as importantly, we really have focused on demystifying things like Twitter, and this will extend to Facebook and others over time. A lot of businesses, 10% are on, but 90% are not, and to a lot of businesses, there's just explaining the business value and allowing them to come into CitySearch directly and use CitySearch as their Twitter client, with an explanation of again, how to appropriately reach out to consumers, what to put through their Twitter account, and making the interface very simple has been a big focus of ours. And then finally, we've pulled in Twitter and Facebook details into the core listings data. And again, that sort of just goes to our philosophy that we want to provide consumers the insight to go interact with content wherever that small business chooses to have their presence. That may be a website, it may be a phone call, it may be a Twitter stream, it may be a Facebook page. On the next slide here, you'll just see another quick example of how we've pulled Twitter into our new iPhone app, which I encourage all of you guys to install. It's gotten a bunch of great reviews. We're excited about it. But it's really the first local app that's aggregated, again, Twitter content against 19 million business listings in the app. So you can do fun things now, like if you're sitting in a restaurant and there's Twitter content about that restaurant, you could pull it up real time, and rather than read a review from 3 weeks ago, you might see that the skirt state is like the special of the day that you shouldn't miss, or you might see that Lindsay Lohan is sitting in a booth next to you. So there's a bunch of kind of great real-time applications that you can imagine coming out of this experience. And then finally, just if you look at what some other manifestations of this trends or enablers of these trends, Twitter's obviously and Facebook now have rolled out lat-long coordinates associated with tweets and status updates, and I'm sure merchant interactions at a deeper level are next. And this this is the first step in taking this content and making it available to structure against business listings and make useful. So, and then finally, your brain can sort of run wild as to the number of potential future applications when you actually do structure this Twitter content and check-in content and basically real-time, on-the-go content against real applications. There's things you can do like filters. I'm on the go. I'm in the mission. I'm looking for a happy hour. Quick filter. Who's tweeting, checking in, status updating about happy hours, and you just pop those onto a map. You make it very visual. You have quick directions, and you're there. Real-time deals is another big one. Voyeurism, dating. Again, the mind can run wild. So. That's kind of I think a quick overview of how we're thinking about the evolution of local data and content in this increasingly networked world. We're definitely putting our money where our mouth is in terms of investing in this distributed model where we now power hundreds of publishers, including almost every large local publisher out there, MySpace Local, MapQuest, Superpages, Local.com, et cetera, and a whole host of local mobile applications as well. And things are exciting and going very well here. So we are definitely the last pitch I will say is we are looking for great people. So if anyone is out there and looking for their next thing, give us a ring.
All right. Thank you very much, Kara. Does anybody have any questions for Kara? Looks like there's a question about Lohan sitting in the booth next to you from Max.
A very substantive one. Get myself into trouble. No, the idea here is we're playing around with the kind of heat map applications where you can use Twitter activity and other forms of check-in activity to make decisions about where to go nearby, or if you're in a new city, and it can be a crude filter. And then there are ways to make it a more granular filter if you're looking for something specific. But the other interesting byproduct is you can actually use those applications to be a bit voyeuristic. Often I sit in Los Angeles, and often I was going to a restaurant last weekend, and I literally pulled up the Twitter stream, and I got sort of a running list of the celebrities who had eaten there in the past week, and it's just that's just fun data. So you could be sitting in a restaurant or a bar waiting for your table, and get the heads up that someone exciting is sitting next to you, or you might just hear chatter from someone nearby that might lead you to want to engage with them in the real world. So there are sort of use cases like that we won't conceive of, but that getting this real-time data can enable.
All right. And Mike Dobson wanted to know how you assess the validity of user inputs.
Yeah, Mike, that's a really good question. This is absolutely a work in progress and a huge problem to solve, but we're doing a variety of things. I mean, one thing we do is we basically look for a certain amount of user input. So we take user input from, kind of gold or approved registered users who've given us good data in the past, and we'll probably streamline that in a different way than we would a new user. Second, we'll look for a certain number of inputs. So particularly if it's coming from a new user, if we just get a correction that came from one user, we'll actually look for that to come from 5 users before we think that's kind of an accurate assessment. Third, we're playing around with a lot of services like Mechanical Turk and others just to get low-cost ways to validate the data. And then fourth, and this is a bit longer term for us, we have so many different sources of data, and because we interact with so many different partners, they can push data back to us as much as we push it to them, because everyone has an interest in making sure the core data set is accurate. So we can actually look at inputs from a variety of partners as well as users and merchants and verify it against at least one other data source. But it's a big area of continued improvement and innovation, I think, for everyone in the industry, and it's definitely something that we spend a lot of time staffing and thinking about.
All right. Thank you very much, Catherine. Yelp also has a pretty interesting model for validating their data. They also use Mechanical Turk, but then they have their regular users and they have Yelp Elite, and then they do a lot of mechanical evaluation. And Yelp will be at Where2O talking about that. That concludes it for today. Where2O is in 3 weeks. We're 3 days. First day is workshops, and the other days we're going to be delving into kind of the more business and technical previews of local, mobile, and mapping applications and companies. So I'll stay online for any more Q&A, and thanks to Joe, Diane, and Kara. And to Catherine for organizing.
Thanks, Brady. This is Catherine again. I just want to tell everyone thank you for joining us here today. And we will have the recording available very shortly, and I will send everyone a link as soon as that's available. I don't know if we should, Marcy says we should have the slides soon. We'll see if we can get the slides posted on SlideShare. Thank you, everyone.